Alright guys, this is 10.3, so hopefully you've already taken your quizzes and we are watching this video. Please make sure you are taking notes on your green sheet. If you do not finish these notes before the end of the hour, you still need to pick up the 10.3 homework, and you will need to finish the video on your own over the weekend for homework. So for 10.3 notes, we're going to start with a theorem, and the theorem says that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that means is that we have this picture over here, and it's saying that if this is a circle, and if you're either in the same circle or you're in two circles that are congruent, meaning their radiuses are the same, two arcs, so AB, is going to be congruent to CD if the chords are the same. So if I know this chord is 8 and I know this chord is 8, then that means that the radiuses are going to, or that the arcs are going to be the same length. So we're going to actually, we're going to do example 1, which kind of goes off of that. So in example 1, it says in circle P, circle P is congruent to circle Q, and FG is congruent to JK. So FG is this chord right here, and see how it has a red bar? That means it's congruent to JK over here. So since the chords are congruent, then that means the minor arcs must be congruent. So that means the arcs that they intercept, so GF and JK are going to be congruent. So since JK is 80, that means that FG is also 80 degrees. Okay, so we're going to move on to another theorem. So the next one is called the perpendicular chord bisector theorem. So it says if a diameter of a circle, it says of a circle is perpendicular, so that means it's going to intersect to make a 90-degree angle, to a chord, then the diameter bisects both the chord and its arc. So that's a lot of fancy words. So all that means is that if this is the diameter, okay, and it's perpendicular to a chord, and we know it's perpendicular because it makes this 90-degree angle, then that means it makes two congruent segments here and here, and it makes the arcs congruent as well. Let me erase that whole picture because that looks jacked up. So it's saying if this is the diameter and this is the chord and they intercept to make a 90-degree angle, then it's going to cut this chord in half. So if the whole thing was like 20, then this side's going to be 10 and this side's going to be 10. And it's going to intercept the arc, meaning that the arcs are going to be congruent. So if this is 20 degrees, then this arc is 20 degrees. Okay? So we're actually going to skip over theorem 10.8, or this theorem real quick, and we're going to come down to example 2. So example 2 says, I want to find HK to begin with. So we have J, I don't know what that letter would be. It's cut off right now. JL, it's an L. So JL, and JL goes through the center of the circle, so it has to be a diameter. And then that makes HK here a chord. Since the chord and the diameter are perpendicular, then it cuts this chord into two congruent pieces. So if NK is 7, then that means this side is also 7. I want HK, so I want the whole thing. So I'm going to take 7 plus 7, and that gives me 14. So the whole length is 14. Part 2 says I want the arcs, okay? So not only does the chord get cut in half, but so does this arc. So that means 11x is going to be equal to 70 plus x. So we're going to solve for x by subtracting x on both sides. So that gives me 10x equals 70 and x equals 7. So But the directions didn't ask me to just find x equals 7. It said find this entire arc length. So what I'm going to do is I'm going to plug this into one side. So 11 times 7 is 77. Well, that tells me half of it is 77. So I can take 77 times 2 because there's 2 of them. And that gives me... I'm looking for a calculator. Hang on. 77 times 2 is 154. So it's 154 degrees. So the chord gets cut in half and the arc gets cut in half. Okay? So now we're going to go back up here to this one. And this is actually just the converse to what we just talked about. And we're not going to do really a lot with this. But it says if one chord of a circle is congruent, I'm sorry, not congruent, perpendicular. To another chord, then the first chord has to be a diameter. So it says, all right, if you have a chord, and you have a chord, and I don't know if that's the diameter because I don't know where the center of the circle is. If they are perpendicular to each other, then SQ has to be a diameter. And see, we didn't know it was a diameter because they didn't give me the center of the circle. So I didn't know that SQ went through the center of the circle. But if it's perpendicular to another chord, that means that it is the diameter. Okay. All right, so it says we're doing a monitoring progress, so this is going to combine the first two things that we've talked about. So it's just like a review of the first things. So it says you got circle D. It says if the measure of angle A of the arc AB is 110, find the arc of BC. So I don't know this arc length. But what I do know is that since this chord is 9 and this chord is 9, if the chords are congruent, then the arcs must be congruent. So then BC has to be 110 degrees. The next part says, okay, same picture, but if AC is 150 degrees, find AB. So I need this. Well, if AB is X, that means BC is X. And a whole circle adds up to 360. So what I can do is I can take 150 plus X, and that should add up to what a whole circle is, because that would be this arc plus this arc plus this arc, making the whole circle. So I'm going to subtract 150 from both sides, and I'm going to combine the x's. So x plus x is 2x. Subtract 150 from both sides, and you get 360 minus 150 is 210. So I'm going to divide both sides by 2. And that gives me that x is 105 degrees. So each arc AB is 105, and so is BC. Okay, so in exercise 3 and 4, it says find the indicated length or arc measurement. So we know this is a diameter, and I know it's a diameter because it's going through the center of the circle. And this is a chord because it's connecting two sides of a circle. So this is that second theorem we talked about, meaning that it's going to cut this chord into two congruent pieces. So if that side is 5, this side is also 5. It's asking for CE. CE is the entire thing. So 5 plus 5 is 10. The second problem says I want the arc of CE. So I want this entire measurement here. Well, what I know is that since these chords are congruent, so are the arc lengths. So I can set 9x equal to 80 minus x, and I can solve for x. So I add x to both sides. That gives me 10x equals 80. Divide by 10. So x is 8. but I haven't solved the problem yet. I want the entire arc measurement. So what I can do is I can take that x and plug it into either side. I'm going to plug it in over here, so 80 minus 8 is 72. That means this half is 72, and this half is 72. So to get the whole thing, I'm going to take 72 times 2, which is 144 degrees. And make sure you pause as you're watching this if you need more time than what I'm giving you. Okay, so theorem 10.9, this is the last one. It says that in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant, meaning equal distant, from the center. So in example 3, it gives us a lot of information. It tells me that QR here is 16, ST is 16, CU is 2x, CV is 5x minus 9, and it wants the radius of the circle. So what our last theorem said was that those chords, QR and ST, are only going to be the same, so they only can both be 16, if the distance from the center is the same. So if this distance here is equal to this distance here. So since we were given that the chords are equal, since they're both 16, I know that the distance from C to U, which is 2x, is going to be equal to the distance from C to V, which is 5x minus 9. So I can solve. So I subtract 2x. Oh, shoot. I should have added 9. Darn flaggots. So I get 9 equals 3x, or you could have gotten negative 3x equals negative 9. Either way, divide by 3. So x is 3. Okay, so all we found was that x was 3. The question said find the radius. A radius goes from the center to an outside of the circle. I didn't find that. All I found was this little part. But what I do know is that since I found that, if it's 2x, that means 2 times 3. This side is actually 6. This side is 6 now. And I know that this is cut in half because it's perpendicular. So this part is 8. So what I have is I know this part is 8. I know this part is 6. And I want this side. Well, this should look familiar. This is a right triangle. You're going to do Pythagorean theorem. So you're going to take 8 squared plus 6 squared, and I'm solving for x squared. 8 squared is 64, 6 squared is 36, and we don't know x squared. 64 plus 36 is 100. So that means x equals 10. Okay. You might be confused, so I'm going to kind of go back through this. So I'm going to erase everything I started with. We're going to go back through this. So we started by knowing that QR is 16 and ST is 16. Since those are equal, the last theorem said that that means that this 2x and this 5x minus 9 have to be equal to each other. So we set them equal to each other, and we solved. That's what this portion was. And we said, okay, that means x is 3. But that didn't answer my question. My question was, I want the radius of the circle. And this little piece here is not a radius. So I said, all right, well, let's plug that in. So 2 times 3, that gives me 6. So I know that I've got this little side being 6. Well, from earlier, we know that if a chord intersects with a diameter, it cuts this piece into half. So since the whole thing was 16, that means this side is 8 and this side is 8. All right, so I know this is 6 and this is 8, and oh wait, I need a radius. So what I did was I created a right triangle. Whenever you have right triangles, you do the Pythagorean theorem. So we do 8 squared plus 6 squared equals x squared, and we solve for x. So this is your answer. Not this x is 3. That helped us get to the answer. Your actual answer is x equals 10. If that doesn't make sense, I'd be more than happy to help you through this on Monday. Do as much as you can on the homework, and it'll be great. Thank you guys so much for being good for the sub. Hopefully you've been good for the sub. And I appreciate your guys' flexibility and everything we're doing. We will make sure we come back to this on Monday. We're going to do 10-4 on Monday. That's the last section that we're going to cover before spring break. Then we're going to have a couple days to review, and then we're going to test next week. So have a great weekend.